Hey there, deep divers. Ready to go deep?
Always.
Today we're diving into the world of U.S. Navy diving systems and procedures. Our guide, the U.S. Navy Diving Manual, Volume 1, Chapter 4, Dive Systems.
Sounds intense.
It is. This manual is packed with incredible details about the equipment and protocols that make these underwater missions even possible.
You know what really strikes me is how much emphasis they place on safety.
Oh, absolutely.
Yeah.
It's a high-stakes environment down there.
For sure. And the first thing that jumps out at me is this strict hierarchy they have for maintaining all the equipment, almost like a chain of command for making sure everything's working perfectly.
Yeah, no room for error. Right.
Right. You start with the planned maintenance system, the PMS documents, and system drawings. Those are your go-to for any questions.
Okay, so those are like the top of the chain.
Exactly. Then you've got the military operating and maintenance manuals, the O&M manuals.
Got it. So if the PMS documents don't have the answer, you go to the O&M manuals.
You got it. And if those still don't have what you need, you consult the manufacturer's technical manuals.
So it's like a built-in safety net, making sure everyone's on the same page, referencing the most up-to-date information.
Precisely. And speaking of specifics, not just any piece of gear gets the thumbs up for Navy diving.
Oh yeah, I noticed that.
They have this authorized for Navy use list, the ANU list, managed by NaviC 00C.
It's like an exclusive club.
It is. And what's interesting is how they distinguish between the equipment categories on the list. Category I is all about life support.
The essentials, the stuff you can't dive without.
Exactly. Oxygen supply, regulators, that sort of thing.
Makes sense.
Then you've got Category 2. This covers equipment that enhances the mission but isn't strictly life-sustaining.
So more like specialized tools or maybe an advanced dive computer.
Exactly. 2 tiers of gear, all carefully vetted.
But who actually certifies that all this stuff meets the Navy's crazy high standards?
That responsibility falls to the System Certification Authority, or SCA. They rigorously test and certify all the equipment. And different organizations within the Navy handle this process depending on the type of system.
Oh, so it's not just one central authority.
Right. You've got afloat systems, shore-based systems, deep submergence systems. Each has its own dedicated team.
So it's like a multi-layered system of checks and balances. And once a piece of equipment is certified, it then enters the planned maintenance system, the PMS, to keep everything in tip-top shape.
Right. A super detailed schedule of inspections, cleaning, and replacing parts, all to prevent issues before they even arise.
Now, here's something that really jumped out at me. The manual specifically says that only white virgin Teflon tape, meeting specific military specs, is allowed on Navy dive life support systems. That's incredibly specific.
It is, but it just shows the level of detail they're paying attention to. Even a seemingly minor material flaw could have major consequences.
No room for error.
Exactly. And that same principle applies to modifying equipment. Absolutely no modifications are allowed without proper authorization.
So let's say you have this brilliant idea for improving a piece of diving gear. You can't just go ahead and implement it.
Nope. You have to go through a formal process. Submit a request to the program manager responsible for that specific equipment and get their approval.
So they have to assess the potential impact on safety and make sure any changes don't compromise the system's integrity.
Right. It's a balance between innovation and safety.
Makes sense. Now, let's talk about operating and emergency procedures, or OPSFPs as the manual calls them.
Ah, yes. The diver's Bible for safe operation.
Exactly. They cover everything from routine tasks to dealing with potential emergencies. And I noticed they use a 2-person integrity system for following these OPs. Why is that?
Well, think about it. You have one person reading the steps aloud and the other person actually carrying them out.
Oh, so it's like a built-in check.
Exactly. It reduces the chance of someone skipping a step or misinterpreting an instruction, especially in those high-stress situations.
So critical procedures are followed meticulously. It's like having a second set of eyes to catch any potential mistakes.
Right. Any deviations from the procedure or any equipment issues are meticulously documented.
So they're constantly learning and improving.
Precisely.
Now, switching gears a bit, let's talk about breathing gas purity standards.
Yes. Crucial stuff. Divers are literally relying on this air to survive.
No room for error there.
Definitely not. And the manual lays out incredibly specific purity standards for divers breathing air. For instance, did you know there are maximum allowable levels for contaminants like carbon dioxide, carbon monoxide, and even oil?
Yeah, I saw that. They even specify the maximum acceptable dew point. What's the reasoning behind that?
Well, moisture can condense and freeze in cold environments, which can cause equipment malfunctions. They even have different dew point requirements depending on the type of diving system. For instance, submarine diving systems have a more lenient dew point standard.
So it's not one size fits all. They've really thought about the specifics of each type of diving operation.
Absolutely.
But where do they even get air that meets these crazy high standards?
You've got a few options. Certified air compressors, those specifically approved for Navy use, or they can even procure air from commercial or foreign military sources, but with very strict certification requirements.
So you can't just grab a tank from the local scuba shop.
Haha, definitely not. And even with a U.S. military compressor, you can't just assume it's producing clean air. That's where the diver's air sampling program comes in.
Oh, right. That's managed by Navicia code 000C3, isn't it?
It is, and they're regularly testing the air from these compressors to ensure it's safe for the divers, taking samples every 6 months whenever contamination is suspected and after a system overhaul.
Sounds...
It is, and if a compressor is suspected of producing contaminated air, it's immediately taken out of service until proven safe.
No messing around there.
Nope. When it comes to diver safety, there's no room for compromise.
I see they have a couple of options for who actually analyzes these air samples,
Yeah, they can go through the Naval Surface Warfare Center Panama City Division.
which coordinates with a commercial lab. Right?
Exactly. But commands can also use certified local government or commercial air analysis facilities as long as they meet the Navy's certification standards.
Seems like they have a backup for everything. And then there's the portable air monitor, the PAM.
Right. The PAM can perform some field tests for contaminants, so it's a handy tool for quick checks.
So more of an early warning system, not a replacement for the full air sampling program.
Exactly. Now let's move on to some of the key components that make up these dive systems, starting with the diving compressor.
The workhorse of the operation.
For sure. These are the machines that provide that pressurized air that divers need to breathe underwater. And the manual focuses specifically on reciprocating compressors. Those are the only type authorized for Navy air diving.
Any particular reason for that?
Well, reciprocating compressors are known for their reliability and ability to generate high pressures.
So they're perfect for the demands of a diving operation.
Exactly. And the manual also gets into the specifics of compressor lubrication, really highlighting the potential dangers of contamination if the system isn't maintained properly.
Right, because the compressors use oil for lubrication, and you definitely don't want that ending up in the diver's air supply.
Absolutely not. The manual even specifically warns against using a malfunctioning compressor to pump divers' air because of that contamination risk.
So something as simple as lubrication can have some pretty serious consequences.
It can. And speaking of things that need careful management, let's talk about how they control water vapor in the air supply.
Because too much moisture can cause problems, right? Corrosion, freezing.
Exactly. They use a combination of compression and cooling techniques. As the air is compressed, its relative humidity decreases. And then by cooling the air, they can condense out more of the moisture, which is then drained away from the system.
Pretty ingenious.
It is.
And once they have this compressed, dry air, they need to store it. That's where the high-pressure air cylinders and flasks come in.
You got it. These are specially designed vessels that can hold air at extremely high pressures, typically over 600 CI.
Yeah, and the manual is very clear about the labeling requirements for these cylinders.
Oh yeah, they have to be clearly marked as divers air supply do not touch.
Can't be too careful, right?
Yeah.
You don't want anyone accidentally tampering with the diver's air supply.
Exactly. And these cylinders are usually part of a larger system, with piping, manifolds, filters, and pressure regulators all working together to deliver a safe and reliable air supply to the divers.
A whole network of equipment. It's amazing how interconnected everything is.
Yeah, it is. And it's a good reminder that a diving system is only as strong as its weakest link. Speaking of interconnected systems, have you ever heard of a pneumofathometer?
It's a remote depth gauge, right?
It is. It allows the surface team to keep tabs on the diver's depth in real time.
Super useful, especially when communication with the diver might be limited.
Exactly. And the way it works is pretty fascinating. It uses air pressure to measure the height of the water column above the diver.
So it's kind of like the high-tech version of tying a rope to a weight and seeing how much goes overboard?
Exactly. The pneumofathometer does the same basic thing, just with way more precision.
Technology has come a long way.
It has, and this is just one of the many fascinating pieces of equipment we'll be exploring in this deep dive. But for now, let's take a closer look at another crucial component of these dive systems, the gauges. It's easy to get caught up in the impressive equipment,
Yeah.
but the humble gauge is arguably just as important.
Right. They're like the dashboard of the whole operation.
They really are. They give both the divers and the surface team all the info they need to make critical decisions.
Absolutely. So what kinds of gauges are we talking about here?
Well, there's a whole range, each with a specific purpose. You've got your pressure gauges, your depth gauges, gauges that monitor air supply, you name it.
So many gauges. And the manual's really clear about choosing the right gauge for the job, too.
Yeah, for example, the full-scale reading of a gauge should ideally be about 130 to 160% of the maximum operating pressure.
So there's a safety margin built in?
Right. You don't want a gauge maxing out right at the critical pressure point.
Makes sense.
It's about making sure the gauge can handle the pressures it might encounter and still give accurate readings.
Yeah, even in extreme conditions.
Exactly. And the manual also emphasizes choosing gauges with the right accuracy and precision for the specific task.
Right, because a gauge used to measure the pressure in a storage tank wouldn't need to be as precise as one used to monitor a diver's depth.
Right, precisely.
Makes sense. What about depth gauges? Are there any specific considerations for those?
Absolutely. Depth gauges, especially for deep-sea diving, need to be super accurate. Even small errors in depth readings can have a huge impact on decompression calculations.
Which are life or death.
Exactly. Speaking of deep-sea diving, the manual mentions a specific type of gauge that's often used, the helical Borden tube gauge.
Okay, and what's so special about this gauge?
Well, they're known for their accuracy and durability. They use a coiled tube that expands or contracts with pressure changes.
Oh, cool.
And that movement is translated into a reading on the gauge's dial. Simple, but incredibly effective.
Even under extreme pressure.
Right. But no matter how well designed a gauge is, it's only as good as its calibration.
You're telling me.
The manual stresses regular checking and calibration of all gauges.
To make sure they're providing accurate readings.
Exactly. They even outline procedures for comparing gauges against a known standard.
To ensure they're within acceptable tolerances.
Right. Another example of the Navy leaving nothing to chance when it comes to safety.
Absolutely.
Yeah.
But even with regular calibration, these gauges are still delicate instruments.
Oh, yeah, for sure.
They need to be handled carefully.
The manual emphasizes protecting gauges from shocks, vibrations, and impacts. They even suggest using protective enclosures.
Especially in the harsh conditions of a marine environment.
For sure.
Now, we talked a lot about air purity already.
Right.
But I'm curious about the specifics of the air sampling process.
Okay.
The manual mentions taking samples as close to the compressor as possible.
Yeah, that's important.
Why is that?
Well, you want to sample the air that's actually going to the diver, so you need to take the sample downstream of any filters or moisture separators.
So you're getting an accurate picture of the air quality after it's been purified.
Exactly.
But wouldn't there be air in the storage tanks and other parts of the system that could potentially contaminate the sample?
That's a good point. And the manual addresses that too. You need to purge the system of air from other sources before taking the sample.
Oh,
That ensures you're only testing the air coming directly from the compressor.
gotcha. It's all about accuracy.
It is. And to make sure the results are consistent, they even provide instructions on how to set up the system and prep the compressor for sampling.
So it's a standardized process.
Exactly. It minimizes variability and ensures the accuracy of the tests.
Makes sense.
Yeah.
It's amazing how much thought goes into something as seemingly simple as collecting an air sample.
Yeah, but when you think about the consequences of contaminated air,
It's worth it.
absolutely. Now, speaking of consequences, let's talk more about operating and emergency procedures, or OPEPs.
Yeah, let's dive deeper into those.
They are the detailed instructions for every aspect of a diving operation, from setting up the equipment to handling emergencies.
The rule book.
Exactly. They make sure everyone involved in the dive knows what to do in any situation.
So they ensure everyone's on the same page.
And working together effectively. Now, the manual distinguishes between standard dive systems and non-standard systems when it comes to OPEPs.
Oh, okay. What's the difference?
Well, standard diving equipment, like the MK3 lightweight diving system, comes with standard OPEPs. These are included in the system's manual and have been vetted by the Navy. They're like the gold standard.
So for standard equipment, there are pre-approved procedures to rely on.
Exactly. But for non-standard systems, which might include custom-built or modified equipment, you need command-level OPEPs.
Interesting.
These are developed by the command using the equipment and have to be approved by either Navi SIA 00C3 or NaviFac of FPSDA, depending on the system.
So there's an extra layer of scrutiny for non-standard systems.
Right, to make sure the procedures are safe and appropriate for the specific equipment.
Makes sense.
And the approval process for these command-level OPEPs is pretty thorough. They have to submit documentation, drawings, and even undergo an on-site survey.
Wow, they really make sure everything is up to par.
They do. And regardless of the system, standard or non-standard, the manual emphasizes using a consistent format for OPEPs.
For clarity and consistency.
Exactly. So everyone can understand and follow the instructions, especially in a high-pressure situation.
It's like a universal language.
It is. And to minimize confusion, the manual also highlights the importance of that two-person integrity system.
Oh, right, for carrying out the OPEPs.
You got it. One person reads the steps, the other performs them, confirming completion.
And the reader initials to document that everything was done correctly.
Exactly. Built-in checks and balances to help prevent mistakes.
So simple, but so effective.
It is. And they even stress documenting any deviations from the procedure or any issues encountered.
To create a record for future training and system improvements.
Right. Constantly learning and refining the process.
It's all about that continuous improvement.
Absolutely.
The Navy has created an amazing culture of safety around diving operations.
It's true. From equipment maintenance to procedural development, it's all meticulously designed to minimize risk.
And ensure the well-being of the divers.
Yeah, absolutely.
Speaking of venturing beneath the waves, it's time we talk about deep-sea diving.
All right. Now that's where things get really intense.
You know, right? I'm ready to hear about it.
Well, first, let's just consider the sheer force of the pressure at those depths. For every 33 feet you descend, the pressure increases by 1 atmosphere.
Oh.
So at a depth of 330 feet, you're experiencing 11 atmospheres of pressure.
That's crazy. Over 1,600 pounds of force pressing down on every square inch of your body.
Imagine that. It's incredible how they engineer equipment to withstand that.
Is
Deep-sea diving suits, called atmospheric diving suits, or ADS, are basically like mini submarines. They maintain a constant internal pressure of 1 atmosphere, regardless of the external pressure.
Sounds pretty high-tech.
They are. They require sophisticated life support systems, pressure-resistant materials, and specialized manipulators for the diver to work with.
It's like science fiction.
I know, right? But it's real, and it's allowing us to explore shipwrecks, conduct research, and even make complex underwater repairs at incredible depths.
That's amazing.
Yeah.
But it's not just the pressure they deal with.
Right. Deep-sea divers also have to deal with the physiological effects of breathing gases under pressure.
Right, we talked about air purity, but in deep-sea diving, even the composition of the breathing gas itself is a concern.
You got it. At great depths, breathing regular air can lead to nitrogen narcosis.
Nitrogen narcosis?
Yeah, it can impair judgment and coordination. Sort of like being intoxicated.
So like getting drunk underwater.
Kind of. And to avoid that, deep-sea divers often use special breathing gas mixtures like heliox.
Heliox.
Right, where helium replaces nitrogen. Helium is inert, so it doesn't have those narcotic effects.
So it's safer to breathe at depth.
Much safer. They might also use trimix, a blend of helium, nitrogen, and oxygen.
Oh, wow.
With the proportions tailored to the specific depth and duration of the dive.
That's incredible. So even the air they breathe has to be specially formulated.
It does. The whole science behind breathing gases under pressure is super complex.
It sounds like it.
Requires a deep understanding of human physiology.
And how different gases affect the body in those extreme conditions.
For sure.
It's amazing how something we take for granted on the surface, like breathing, becomes such a complex issue underwater.
I know, right?
It really shows how much goes into making deep-sea diving possible.
It does.
Well, I think we've covered a lot of ground here.
We have.
Let's take a break and come back to explore another crucial aspect of Navy diving: the handling and storage of compressed gases. Welcome back, deep divers. We've explored the equipment, the procedures, and even the crazy challenges of deep-sea diving.
Yeah, it's been quite a journey.
It has. But there's another crucial piece of the puzzle we need to talk about:
What's that?
the safe handling and storage of compressed gases.
Ah, yes. That's essential.
Absolutely. Without a reliable and safe supply of breathing gas, none of it would be possible.
So true.
And the Navy Diving Manual is super thorough on this aspect.
It is. Really covers all the bases.
I noticed they frequently mention Department of Transportation regulations, the DOT regulations.
Oh, yeah. Those are important.
Why are those so crucial in the context of diving?
Well, DOT regulations are like the gold standard for safe transportation and storage of compressed gases,
Okay.
and they apply across the board, diving, industrial applications, medical uses, you name it.
So it's not just specific to diving.
Nope. They cover everything from cylinder design and testing to labeling and handling procedures.
So whether you're filling a scuba tank or transporting industrial gases, these DOT regulations provide a common set of safety guidelines.
Exactly. A framework to help minimize the risk of accidents.
Makes sense. And the manual specifically references DOT regulations for the cylinders used to store and transport diving gases.
Right. Those cylinders have to meet strict standards for material strength, pressure testing, valve design.
To make sure they can handle those pressurized gases.
Exactly. You wouldn't want a cylinder failing under pressure, especially with a flammable gas like hydrogen.
Definitely not. And DOT regulations also mandate clear labeling for the cylinders.
Right. Each cylinder needs to be clearly marked with what's inside the pressure rating and any potential hazards.
So everyone handling them knows exactly what they're dealing with.
And how to do so safely. It all comes down to minimizing the risk of human error.
It really seems like every step of the process is designed with that in mind.
It is. They even go into detail about cylinder valve design,
Oh, wow.
referencing standards that ensure different gases have unique valve connections.
Okay, so that's to prevent someone from accidentally connecting a hydrogen cylinder to an oxygen system or something like that.
Exactly. They've thought of everything.
It's incredible. The level of detail they go into shows how seriously they take safety.
They don't mess around.
And I see they also emphasize the two-person integrity system when filling and handling these cylinders.
Oh, yeah, that's crucial.
So one person handles the cylinder and the other monitors the process, double-checking everything.
Exactly. It's all about redundancy and accountability, working together to make sure everything's done safely.
It's amazing how that two-person system is used in so many different procedures.
It's a core principle of their safety culture.
And that focus on safety extends to cylinder storage as well.
For sure. The manual's very specific about storing cylinders in well-ventilated areas, away from heat and potential ignition sources.
To minimize the risk of an accident.
Exactly. Whether it's a fire, an explosion, or even just a cylinder falling and hurting someone.
Right, safety first.
Always. They even address the disposal of those cylinders.
Oh, wow, they really do cover everything.
Making sure they're vented properly and disposed of according to regulations.
It's incredible how thorough they are.
It is. It shows their commitment to safety.
Right.
And it's a reminder that no matter the application, safety should always be the top priority.
Well said.
Whether it's diving industry, healthcare, whatever it is, clear procedures, proper training, and a vigilant mindset are essential.
Couldn't agree more.
It's all about preventing accidents and keeping everyone safe.
Well, I think this is a perfect place to wrap up our deep dive into the U.S. Navy Diving Manual.
Sounds good to me.
We've learned so much about the equipment, the procedures, the incredible safety protocols that govern every aspect of their operations.
It's been a fascinating look into the world of underwater exploration.
It really has. And for all you deep divers out there, I encourage you to keep exploring, keep learning, keep pushing the boundaries of knowledge. The underwater world is full of wonders and mysteries waiting to be discovered.
Absolutely. Keep diving deep, both literally and figuratively.
And never stop being curious about the world around us.
Well said.
And until next time, deep divers, stay curious.